So for question 33, right, we've got this nitrosyl chloride breaks down into nitrogen monoxide and chlorine. And they tell us, right, they tell us right in the question for 33 that the reaction is second order. So that means that my equation is going to be 1 over, right, the concentration of nitrosyl chloride at some point in the future equals my rate constant times time plus 1 over my initial concentration. And we know that because they tell us in the question that it's a second order reaction. So that's the rate law we want to use. And then also in the question, they tell us the rate constant for this reaction is 3.2 inverse molar inverse seconds. So if they didn't tell us, right, this was a second order reaction, we should also know that those units of the rate constant also apply to a second order reaction, inverse molar, inverse seconds, as our second clue. And then they tell us, all right, initial concentration, right? So NaCl at time 0, and then NaCl at some point in the future. My initial concentration is 0.076 molar, and my concentration in the future is 0.042 molar. So from there, I just want to plug everything in. So 1 over my concentration in the future, 1 over 0.042 molar equals K, 3.2 inverse molar inverse seconds, time plus 1 over my initial concentration, 0.076 molar. So I'm going to divide through both of those. So 1 divided by 0.042 is 23.8. Inverse molar equals 3.2 times time plus 1 divided by 0.076. And that's like 13.158 inverse molar. So all we want to do is we want to solve for time. So I'm just going to subtract this across. So I'm going to subtract 13.158 from both sides. So I want to get time by itself. 1.3158 inverse molar. So I'm going to get around 10, something like that. So I get like 10.65 inverse molar equals 3.2 inverse molar inverse seconds. And then the last thing we want to do, right, we're going to just divide by my rate constant to get time by itself. So divide both sides by that 3.2 inverse molar inverse seconds. All right, that cancels out. Molarity cancels out. And then when we divide, right, we can flip the inverse seconds to the top. And let's see, if I divide 3.2, we're going to get like 3.3 or something like that. Yeah, I get time equals 3.3 seconds for that reaction. So it takes 3.3 seconds to go from our initial concentration to 0.042 molar, right? The important thing being from this question that we knew what equation to use because they told us in the question, right? This was a second order reaction. So I knew to use the rate law for a second order reaction. Got any questions on that?